This is dark, and it has huge mass, and it's small. That's 3 smoking guns right there.
Right.
Implicating a supermassive black hole.
Monstrous black holes started destroying the foundation of star formation 11 billion years ago, changing the trajectory of cosmic evolution. The James Webb Space Telescope's observation of the far-off Spiderweb Protocluster revealed this groundbreaking discovery, which highlights a sharp contrast. Galaxies with massive black holes no longer produce stars, while others do. Get ready to discover the mysteries of this remarkable discovery, which has the potential to completely alter our knowledge of how galaxies develop and eventually die. A group of researchers targeted 19 galaxies inside the Spiderweb Protocluster using the near-infrared camera, or NIRCam, on the James Webb Telescope. One of the most distant cosmic communities ever thoroughly examined is this cluster, which is an absurd 11 billion light-years from Earth. By examining these galaxies, scientists discovered that those with supermassive black holes at their centers appear to be depleting their supply of new stars. Stars are still being produced by galaxies that do not have those enormous black holes. However, there is a greater mystery, a secret regarding the destiny of entire cosmic realms that is just waiting to be revealed, hidden within these galaxies. The problem with stars is that they are created when massive clouds of icy hydrogen gas collapse due to gravity. The gas heats up as they become closer together, triggering nuclear fusion and creating a new star. This entire process emits a particular kind of radiation that may be detected by sophisticated devices such as the near-infrared camera. Scientists were able to map this radiation using the James Webb data, which revealed which galaxies are still producing stars and which are not. This is when things start to get interesting. The fact that older galaxies appear to be producing fewer stars than they once did has long been recognized by astronomers. Initially, they believed it was because these galaxies were running out of cold hydrogen, which is necessary for the formation of new stars. Only a billion years old, some galaxies were already shutting down their star manufacturers, which was strange, they discovered. It's much too early to be out of gas. What's the matter, then? Researchers began to speculate that black holes might be the cause. The black holes at the centers of merging galaxies consume an increasing amount of stuff, developing into giants that are millions of times as massive as the Sun. Furthermore, these black holes are not passive objects. They can expel some of the gas they consume in incredibly quick jets. Imagine it as a cosmic blowtorch destroying the very material that stars are made of. An excellent resource for researching this topic is the Spiderweb Protocluster. We're viewing it as it was fewer than 3 billion years after the Big Bang, quite early in the universe's history, because it's so far away. It is also the ideal cosmic laboratory for determining the potential connections between black holes and star formation because it is teeming with enormous galaxies and their supermassive black holes. Known for having very little star production, elliptical galaxies are the large, spherical clusters of stars that you occasionally glimpse in space images. Large galactic smash-ups, in which younger galaxies crash and merge, are assumed to be the cause of these galaxies. When that occurs, their stars start to move in all directions and their tidy spiral forms are destroyed. Furthermore, these galaxies center black holes mix to become even larger black holes. These supermassive black holes have the potential to become the heaviest ones known in the future. Telescopes like NASA's Chandra X-ray Observatory can detect the powerful X-rays released by matter spiraling into one of these gigantic black holes. Scientists discovered something startling when they compared these X-ray readings with the James Webb Telescope star formation data. The galaxies with the most ravenous black holes also had the slowest star creation rates. Scientists have previously noticed indications that black holes may be forcing gas out of galaxies. However, the results of the Spiderweb cluster are particularly helpful since they reveal a recurring pattern among an entire collection of galaxies with comparable ages. 11 of the 19 galaxies they examined had quieter centers, whereas 8 had supermassive black holes that were actively functioning. The team acknowledges that they still don't know a lot. The connection between black holes and their galaxies is likely more complex than we realize, and other forces may be at work. But for the time being, The evidence suggests that black holes play a significant role in determining whether a galaxy continues to produce stars. The idea that black holes form in bursts and consume a lot of matter during brief bursts of high activity is one hypothesis. Galaxy mergers, which direct gas into the galaxy's center and feed the black hole, may be the cause of these explosions. Another theory is that certain black holes were initially much bigger than we presently believe, maybe originating straight from enormous gas clouds as opposed to collapsing stars. These theories are being tested with new data from the James Webb Telescope's ability to peer back in time. The following chapter presents additional James Webb Telescope findings after learning about the effects of black holes on stars. 3 years have passed since the James Webb Space Telescope launched into space with the goal of revealing the early history of the universe. Consider creating a machine whose purpose is to look back nearly to the Big Bang. Doesn't that sound impossible? However, it is precisely what took place. This sophisticated stargazer is on a quest to discover the origins of stars, galaxies, and planets as well as what happens after they are finished, and it is not only there to take beautiful images. The Sombrero Galaxy is one of the more striking finds. Although it has a hat-like name, it doesn't actually look like one, yet it's still cool. We were able to see the smooth inner disk and certain clumps out in the ring that were not visible with standard telescopes because of the observatory's mid-infrared technology. Next, astronomers discovered a black hole that was devouring stuff with an insatiable appetite. Approximately 1.5 billion years after the Big Bang, this creature resides in a dwarf galaxy. Furthermore, it is consuming food 40 times more quickly than experts had previously predicted. One of the brightest stars in the night sky, Vega, received attention in yet another astounding discovery. Hubble displayed a clean disk of fine dust, while the telescope showed heated material blazing in the star's outer regions. The worst part? Vega is lounging with some space pebbles. No large planets are in the area. In the meantime, the observatory and Hubble collaborated to produce a colorful picture of two spiral galaxies doing a cosmic dance, emphasizing regions rich in dust and gas that produces stars. Then there's the space rock Centaur 29P, which orbits between Neptune and Jupiter. Think of it as an asteroid releasing clouds of cosmic gas, and the space device captured it launching jets of carbon dioxide and carbon monoxide. In addition, researchers discovered a galaxy from 1 billion years after the Big Bang in which the gas is brighter than the stars. Scientists think this might be a crucial stage in the evolution of galaxies. Imagine a collision between two galaxies. That's just what the Skywatcher saw in Leo, some 465 million light-years away. The interaction between the two galaxies, one spiral and the other elliptical, has twisted the spiral's arms. As the sensor approached home, it examined the Milky Way's edge, detecting regions of molecular clouds that were creating stars. Massive young stars are seen in the pictures, encircled by dust and gas that swirl. Among the stranger discoveries? A galaxy that resembles a cosmic quiz mark. Gravitational lensing, which occurs when a huge galaxy cluster bends light from someplace much farther away, is responsible for its strange structure. Massive, bright galaxies that were far too large and brilliant for their age were also discovered by early observations between 500 to 700 million years after the Big Bang. The offender? Their luminosity is probably enhanced by supermassive black holes. The stargazer jumped to exoplanets and saw one of the coldest planets ever directly detected, a gas giant a dozen light-years away with a temperature just above freezing. One side of another exoplanet is constantly facing sunlight, whereas the other side is always facing dusk. Unexpectedly, temperatures are over 300 degrees hotter on the sunset side. Two galaxies known as the Penguin and the Egg in Hydra were photographed by the observatory to commemorate its second birthday. These strange formations are the result of their continuous collision, which began millions of years ago. An hourglass-shaped cloud of gas and dust encircled a protostar in another young star observation. It is still in its infancy, consuming matter to develop into a fully formed star. We also got a close-up view of the Serpent's Nebula, which is where new stars are formed, at the observatory. Red streaks, which are gas jets erupting from these developing stars, are abundant throughout the nebula. The explorer of the sky discovered intricate filaments of gas and dust as well as areas where new stars are developing in the Crab Nebula, which is supernova debris located approximately 500 light-years away. Scientists noticed another twin newborn star system. There are jets of gas radiating out in opposite directions from these young stars, which are only a few million years old. 3 of the earliest galaxies ever discovered by the observatory were discovered to be 400 to 600 million years after the Big Bang. These galaxies continue to pull in hydrogen and helium gas from their environs in order to produce stars. Unexpected new findings about planets and galaxies are covered in detail in the following chapter. WASP 107b, a puffy gas giant exoplanet that has a hotter core than anticipated due to a significant methane deficit in its atmosphere, was detected by the sophisticated eyes. At the same time, severe wind speeds of up to 8,000 km/h were observed at another gas giant located approximately 280 light-years away. The cosmic instrument displayed detailed information on the interactions between gas and dust in a stunning image of the Horsehead Nebula, which, let's face it, still doesn't look like a horse. A starburst galaxy 10 times faster than the Milky Way was observed generating stars in Ursa Major. Alcohol was even found by the device in the frigid areas of a molecular cloud, suggesting that these molecules existed in the early stages of the formation of stars and planets. Around 2.7 million light-years away, the observatory discovered more than 200 newborn massive stars forming in the Triangulum galaxy. Additionally, it demonstrated the presence of a neutron star at the core of a 1987 supernova. Another odd discovery: certain early galaxies resemble surfboards or pool noodles. It's long, slender, and unexpected. The stargazer discovered carbon dioxide on the frozen surface of Europa, one of Jupiter's moons, indicating that it originated from an underground ocean. Speaking of far-off stars, the cosmic observer managed to catch a glimpse of light from the most distant star ever seen, a big 128 billion light-years away. We were able to see the star because of gravitational lensing, which magnified its brightness. Additionally, a huge plume of water vapor was seen by the Space Telescope emerging from Saturn's moon Enceladus. This approximately 10,000 kilometer plume probably supplies water to Saturn's rings. About 40 light-years away, the equipment even provided us with a close-up view of a miniature Neptune exoplanet with a hot, hazy atmosphere. A super-bright infrared galaxy created by the merger of 2 spiral galaxies is one of the most amazing discoveries. This event caused a massive explosion of star formation 250 million light-years away. Additionally, the instrument took pictures of Cassiopeia A, our galaxy's youngest known supernova, showcasing its growing debris field. Returning to exoplanets, the cosmic device recorded the dayside temperature of the rocky planet 35 light-years away from Earth, called TRAPPIST-1b. Given its intense heat, it is probably stony and desolate since it lacks much of an atmosphere. The gadget also caught a huge star that was going to explode, which was one of the most spectacular discoveries. Huge, bright, and short-lived, these Wolf-Rayet stars explode in a supernova. Gravitational lensing magnified even farther off galaxies in a deep-field photograph of Pandora's cluster, which showed 3 merging galaxy clusters forming a megacluster. Nearer to home, the device captured a tiny asteroid in the main belt between Jupiter and Mars. It's not particularly noteworthy, but it demonstrates that it can locate tiny objects that might one day strike Earth. A dusty disk left behind after planets collided was one of the more spectacular sights, and the Space Telescope photographed it in amazing detail. About 200,000 light-years distant, in the Small Magellanic Cloud, another active star-forming zone revealed a wealth of dust and hydrogen clouds, which are the precursors of stars and planets. The stargazer highlighted molecular hydrogen, which is essential for star formation, by revealing hitherto unseen jets and outflows from nascent stars in the Carina Nebula. Additionally, interactions between several stars in the Southern Ring Nebula produced complex, curved structures. The mass of the central star before it lost its outer layers was determined in cooperation with the Gaia Observatory. The device recorded the iconic pillars of creation in the Eagle Nebula, highlighting gas and dust structures without illumination, in one of its more eerie photos. Another intriguing picture from 11.2 billion years ago revealed a far-off quasar encircled by a cluster of developing galaxies, providing information on the early stages of galaxy formation. Additionally, a binary star system with at least 17 concentric dust rings was discovered by the Sky Observatory. These rings formed as the stars got closer to one another every 8 years. These dust rings, which indicate distinct times in the star's orbits, resemble fingerprints or tree rings. Last but not least, Hubble and the observatory collaborated to watch NASA's DART mission, in which a spaceship purposefully collided with an asteroid to test planetary defense. The telescope also highlighted the weak Zeta ring and revealed 7 moons, giving the finest glimpse of Neptune's rings in decades. For those who are afraid of arachnopods, it captured a high-definition image of the Tarantula Nebula, which revealed tens of thousands of young stars. Finally, the device captured the Cartwheel Galaxy, an unusual ring galaxy created by a high-speed collision, displaying its expanding outer ring and bright inner ring, where stars are forming quickly. Here's a question before we go: when will mankind make its next big leap if we can crash spacecraft into asteroids? For more, subscribe, like, and leave a comment.